Welcome back to the Google Agent Development Kit Masterclass. In part 1 of our deep dive into Google ADK Evaluation metrics, we'll explore the foundational metrics and LLM-as-a-Judge metrics, explained with simple, real-world examples. How does Google ADK actually know if your AI agent is working correctly, without a human manually checking every single response it gives? The answer is a set of built-in evaluation metrics that automatically test both the agent's actions and the quality of its final answers. Every ADK evaluation boils down to 2 core questions. First, did the agent use the correct tools, in the correct sequence, to solve the task? Second, was the final response actually good, accurate, relevant, and safe for the user to see? In this part, we'll break down the foundational metrics and the advanced LLM-as-a-Judge metrics ADK uses to answer both questions. The first foundational metric is the tool trajectory average score. It checks whether your agent called the correct tools, in the correct order, every single time. Example: imagine a shopping agent that should follow this exact workflow: search product, then check inventory, then place order. If the agent follows that exact sequence, the trajectory matches the expected path perfectly, and the score comes back high, close to a perfect match. But if the agent instead calls place order first and only then search product, the workflow is broken. It tried to order something before even confirming it exists. ADK compares this actual sequence against the expected one, step by step, and the score drops sharply because the execution path doesn't match. This metric doesn't need an LLM to run, it's pure comparison logic, so it's extremely fast and deterministic, perfect for regression testing after every code change. The second foundational metric is the response match score. This one checks the final answer itself, not the tools that got there. ADK compares the agent's generated response against a golden reference answer that you write ahead of time, using an algorithm called Rouge 1. Rouge 1 simply counts how many important words overlap between the generated response and the expected response. The more shared words, the higher the score. Example: the agent generates "your order will ship in 3 business days," and the golden reference says "your order ships in 3 business days." Almost every important word overlaps: order, ship, 3, business, days, so Rouge 1 gives this response a very high match score. But word matching has a real limitation. 2 answers can mean exactly the same thing while using completely different words. That's where LLM-as-a-Judge metrics step in. Final response match v2 uses an LLM itself to compare the meaning of the response, instead of just counting matching words. Example: the expected answer is "your refund will arrive in 5 business days," but the agent responds "you'll receive your money within 5 working days." A pure word overlap check like Rouge would score this poorly, because barely any words match. But the LLM judge reads both sentences and understands they say the exact same thing. So final response match v2 marks this as a correct, high-quality response, because it evaluates meaning, not just vocabulary. Next up is rubric-based final response quality. Here, instead of comparing to one fixed reference answer, you define your own custom rules the response must follow. Example rubric for a customer support agent: always be polite, keep responses under 100 words, and never recommend a competitor's product. The LLM judge reads the agent's actual response and checks it against every single rule in your rubric, one by one. If the response stays polite, stays under the word limit, and never mentions a competitor, it passes. If it breaks even one rule, that gets flagged clearly. The last metric in this part is rubric-based tool use quality. Instead of only checking the exact order of tool calls, this judges whether the tool selection itself made good sense. Example: an agent skips an inventory check because it already retrieved that data in an earlier step, or it picks a faster search API over a slower, redundant one. A strict trajectory comparison might penalize this because the sequence looks different from the reference path. But the reasoning behind it was actually smart and efficient. The LLM judge evaluates the intent and outcome, not just the literal sequence, so this kind of smart, efficient tool use still scores as correct. That wraps up the foundational metrics and the LLM-as-a-Judge metrics. In Part 2, we'll cover safety and hallucination checks, multi-turn metrics, and a full production example. Like, subscribe, and share with friends learning AI agents and Google ADK.